Is on geometric sequences. Okay, so we're going to talk about geometric sequences today. So if you're going to notice, I have listed what some examples of geometric sequences are. So it says geometric sequences 2, 4, 8, 16, 4, 12, 36, 108, -1, 4, -16, 64. And then I have a list here that says these are not geometric sequences. Okay? These are not geometric sequences. And so what I want you to do right now is I want you to look at the two. I want you to look at the geometric sequences, the not geometric sequences. And I want you to just kind of look for similarities, differences. What classifies something as a geometric sequence versus what classifies something as not a geometric sequence. So hold on. I'm going to go ahead and let everybody kind of have a chance to look. Okay, so what are some things that you notice about a geometric sequence? Yeah?
Squaring.
What?
Squaring.
Squaring. Okay, what do you notice?
That on the geometric you multiply.
On the geometric, you multiply. So, like up here on the top, what do I multiply by?
2.
So I multiply each and every number by a 2. Okay, so the next term would really be what? 32. On the second one, what do you do?
Multiply by 3.
Multiply by 3 every time. So the next one would be 324. Okay, what do I do on that last one?
Multiply -4.
Multiply by -4. So I can multiply by negative numbers. Let's look at these are not geometric sequences. Now you just said I multiply by something. Let's go ahead and look at that second one. On this one I'm adding. I add by 1 every time. What do I do here?
Add by 2.
Add 2. What do I do here?
Add 3.
Add 3. So real quick, I want you to look at this one for me. Would that be a geometric sequence, yes or no?
No. No, because 1 times 4 equals
What do you do here? You multiply by?
2.
What do you do here?
Multiply by 4.
So would that be a geometric sequence?
Yes.
There's a reason why I wrote it down here, and the answer is
no.
no. Because you have to multiply by the same number each and every time. It's not enough just to say you multiply by a number. So in order for it to be a geometric sequence, you have to multiply by the same number every time. Now there's also something known as an arithmetic sequence. An arithmetic sequence, you have to add the same number every time. So of these, which one would be an arithmetic sequence?
1, 2, 3, 4.
This one would be an arithmetic sequence.
2, 4, 6, 8.
Arithmetic sequence.
4, 7, 10, 13.
This would be an arithmetic sequence. Would this be an arithmetic
No.
sequence?
No.
No, so we call this one neither.
Multiplicative.
Okay. So, let's go ahead and look at this real quick. A little bit about geometric sequences. First of all, the first term can never be 0. Okay, reason being, can somebody guess? It's going to stay 0 no matter what. So the first term can never be 0. You multiply the previous number by the same number. We call that a special name. We call it a common ratio. So, example, if I have 3, okay, and I multiply it by, let's just say we multiply these by, let's go with -5. So the next number would be -15. And then the next one would be, I think it's 75. What would the next one be? Negative, bigger, big,
Negative 375.
-375. Now what we do is we actually call -5 there the common ratio. Okay, -5 we would call the common ratio. And we symbolize that with an R. So that's just a little bit about geometric sequences. So let's go ahead and see how well you grasp the information about arithmetic sequences. Okay, we add the previous number by the same number. We call that the common difference. So let me just tell you the common difference here is 4. Okay, common difference is 4. What would go here?
12.
No.
15.
So the common difference, we would call that the 4. And we symbolize the common difference with, can somebody guess?
D.
A D. Okay.
Oh, as.
Okay, so, and you might have seen arithmetic sequences before. But with that in mind, I want you to now look at this. And I want you to tell me, is this sequence arithmetic, geometric, or neither? So is that sequence arithmetic, geometric, or neither? So is that arithmetic, geometric, or neither? Shouldn't take you that long. If you don't know, take a guess. Okay? Quick, quick, quick. And the answer is
B.
B. Now, for those of you that are trying to figure out, well, what on earth? Okay, what I would suggest you do is look to 64 and 32. You notice they're a half, right? So then the question is, could I take 256 times a half and get 128? Yep. 128 times a half and get 64?
Yes.
Yep. So this one's actually geometric. You're just multiplying every time by 1/2. Okay, so those are things you need to look at. Let's try this one. Okay, is this arithmetic, geometric, or neither? Arithmetic, geometric, or neither? And the answer is A. Nice job. It's arithmetic. What is your common difference on that?
4.
4, because you're adding 4 every time. All right. Oh, skipped one. Let's go back to this one. Arithmetic, geometric, or neither? Arithmetic, geometric, or neither? And the answer is geometric. What is your common ratio? What do you multiply by on this one?
-5.
-5. Okay. Ah, good grief, it's skipping on me. Arithmetic, geometric, or neither? All right, so arithmetic, geometric, or neither? And the answer is neither. Nice job. Okay, that one you actually multiply by 3, 4, and 5. All right, so now it says find the next 3 terms in each sequence. So you've probably done this before. We're just basically going to fill in the blanks. So I'm going to look at what's been done. So I go from 1 to -4 to 16. So I'm multiplying by what? -4. So, oops, let me go and get my pen going. So I'm going to multiply this by -4. What's the first number I get?
256.
256. So now what I'm going to do is I'm going to take 256 times -4, in which case
-1024.
-1024. Multiply that by -4. You should get
4096.
4096, and there you go. That's all you do. Okay, let's look at the next one. What are you doing in that problem? Notice I'm getting smaller.
Divided by 3.
Yes.
I'm dividing by 3 or multiplying by 1/3. It's the same thing. Dividing by 3 or multiplying by 1/3. I would probably look at the multiplying by 1/3 because if I take 1/3 times 1/3, I get 1/9. So basically, here's the easy way, guys. You take your denominator times 3. So leave your numerator at 1. You get 127. and then 1 over 81. So those are little tricks to look for to make things a little more easy for you. Okay, so 1/9, 1/27, and 1/81st. Okay, so let's look at this one. What are the next 3 terms in the sequence?
It's an arithmetic sequence.
It's not arithmetic because I add 12 and then I add 18.
Neither.
So let's think about things. This is the easy way. Let's take 36 and divide it by 24.
Oh my goodness.
When I take 36 and divide it by 24, what do I get? I get 1.5 or 3/2, okay? So what I want you to do right now, okay, obviously we know that 24 times 1.5 is 36. I want you to take 36 times 1.5. What do you get? 54. I want you to take 54 times 1.5 and see what you get. 81. So really, what type of sequence is it?
Geometric.
Geometric, and I'm going to multiply by 1.5. What do you get when you take 81? 121.5, you said?
Yeah,
Okay, keep going.
182.25.
182.25. And what's your next one?
273.375.
273.
272.25 is
I got 273.375.
75.
I did it wrong.
Okay, so
I was smart.
this is one of those things that if you get stuck and you first of all know it's not arithmetic. The next thing to look at is to see if it's geometric, and if it's not obvious, take your second term and divide it by your first. Okay? Take your second term and divide it by your first, and that will give you the ratio. Don't do it the other way around. It's not going to work. Okay, so second divided by first. Okay, so now geometric sequence, this is the formula for what a geometric sequence looks like. So I would highly suggest that you get this down. Okay, it's a sequence in which the ratios of consecutive terms are equal or are the same. This is the formula you need to get down. This is also taken from your book. But you have A sub n. Those are subscripts. What those mean is those are little numbers, little variables written right after something. Okay, so A sub n equals A sub 1 times r to the n minus 1 power. Now let's talk a little bit about what that means. Notice down here what I've already done is I've already kind of said what things are. Okay, this is my first term. So this is where you start. Okay. It's your first term. This is my common ratio. Remember, we already said that R stands for that. And then N is just whatever term you're trying to find. So if you're trying to find the 10th term, N would be 10. If you're trying to find the 100th term, N would be 100. Okay, but you need to get this down, especially for the next few problems that we're going to be looking at. Okay. Once again, if you need to, you can use your book as well. It's got a nice little excerpt there for you to look at. But let's go ahead and look at, oops, I skipped one. Oh my gosh, we're skipping today. Let's go ahead and look at this one. It says, write an equation for the nth term of the sequence. So they actually want an equation. So we know from the slide before that my equation is A sub n equals A sub 1 times r to the n minus 1. So all I'm going to do is fill in what I know. First of all, it's an equation, so it's got to equal A sub n. Okay? Every equation is going to equal that. What's your first term?
-6.
So that's going to go right here, -6. Okay? Notice I've got a times sign. Now I've got my ratio. My ratio is -2. I'm going to go ahead and put that in so that people don't think I need to subtract. And then I'm going to just go ahead and have n minus 1. That's it. That's all you do. That's your answer. You put in your first term, you put in the ratio, and you're done. First term in the ratio, and you're done. Let's go ahead and look at another one. Maybe. Let's see what it says. Find the 9th term of that sequence. So that sequence, if you remember, was a sub n equals -6 times -2 to the n minus 1, right? Find the ninth term. Ninth term is symbolized by what? 9, right? Ninth term means 9. So I'm going to put 9 in place of this and in place of this. Okay? So what I'm going to do here is I'm going to go ahead and sub that in. So what I want you to do right now is I want you to go ahead and calculate that for me and see what you get. Okay, go ahead and calculate that, right? Calculate that for me. So what, did you get a big number?
Yes.
What'd you get?
1,500. Negative 1,536.
Somebody else?
I got 96.
I got 96.
I got
Okay, so what you really should do first, order of operation states you should do these powers. So you should really have -2 to the 8th power. You do not take -6 times -2. The very first thing you're going to do is you're going to do this -2 to the 8th power. Okay, -2 to the 8th power, you should get that to be 256. Should not be negative. The reason why is because it's an even power. Now, if you're doing this on your calculator, you have to learn a little bit about how your calculator works. Okay, you cannot just do this, because what it will do is it will actually do the 2 to the 8th first and then attach the negative. If you're doing this on your calculator, put it in this way and see if you get a different answer, because you will. So that's one thing to be aware of, just for future reference. So now then you have -6 times 256, which comes out to be negative. Is it 1536? Okay, so there you go. So you have to be careful with those positive and negative signs. All right, so let's look at another one. Write an equation for the nth term of the sequence. Okay, so nth term of the sequence. We're going to do the exact same thing we just got done doing. A sub n equals a sub 1 times r to the n minus 1. Now it's an equation, so what do I always know about a sub n? I just leave it alone. What's my first term? 96. Now I need to find my ratio. So remember to find the ratio. If it's not obvious, you take the second and divide it by what? The first. Yep, so I take 48 divided by 96. Now, if that's confusing, you kind of look down the line. You see you've got a 24 and a 12. This comes out to be 1/2. Okay, so I could do 0.5 if I wanted. I mean, that's the same thing as 1/2. I'm sure a lot of you would probably like the 0.5 a little better. So there you go. So now we've got to find a certain term. Let's see what term we're finding. The 10th term. So a sub n equals, it was 96 times 0.5 to the n minus 1. In place of n, what am I going to put? 10. So go ahead and do that. What does it come out to be? Point what? 0.1875. If you're doing this as a fraction, you're going to get like 96 over 1,024, and that'll actually be reduced down a little bit. Okay, but this is your 10th term of your sequence. Questions? Think you can handle that? We learned a little bit about geometric sequences, a little bit about arithmetic. So what you need to do is on page 441, 14 through 31. This is due tomorrow, start a class. A little bit about tests. You're looking at a test probably Thursday of this week.